Mm-hmm. So this is my first broadcast. I believe I am live. Uh, live. Am I? Yep. There we go. I am live, and my OBS studio is telling me select the stream. Okay. YouTube live control panel. No current live streams. I don't know. Some YouTube says I'm streaming. Hello, YouTube. Uh, which screen am I sharing? Hmm. Oh, damn it. There is so much lag in here. Okay. So, don't mind this idle chit chatter that I'm doing right now because this is my first live stream. So, give me a break. Uh, all right. So, let's get started. So, if you have my screen, then let me show you first of all my website, which is cookiesensei.com. And what I want to do today is go to the lab section and just create the slavers. I have created the slavers on the GitHub. If it is visible, then code it. I believe this much font should be readable. So yeah, this is my GitHub. I have created the entire slavers. So you can see the second folder over here, and so many folders are there for the AI bootcamp of 1 month, 4 week bootcamp. So the purpose of this live stream is I will just be talking about all these sections that I have created. Like it's not really a recorded video where you record the video and basically upload it to YouTube. It's just me creating the slavers in front of you so that you guys would know how I did it. If you want to like recreate the entire thing, so you would do that as well. So let's first of all clear throat. First of all, no terminal, no terminal. I want to open my VS Code, which exists in the cloud. So there it is. I gotta talk more about this because it's really that easy. You just go to the website, you enter the lab, and the entire VS Code is there waiting for you. That's it. That's it. I didn't start VS Code. I didn't install Python. Uh, I didn't install any data science library at all. Numpy, Pandas, scikit-learn. I didn't install anything at all. I just clicked on a lab button and everything is right there as I left it previously. So, first of all, let's discuss the NumPy tutorial. So, first of all, like let me tell you why am I making this live stream. This live stream is basically for all the students who would be enrolling with me in the future cohort, and the purpose is that let's say if we are taking live batches, and one of you like forget or forgot what was the thing we studied, why a particular notebook has this kind of code. So that's why I'm creating these live series where I'll be creating the syllabus and explaining everything side by side. So let's start. So we have already covered Python. We have covered how to run basic Python files, and we have covered basic Python as well. So at this point, even basic Python is enough because our purpose of this AI bootcamp of 4 weeks is not to become experts at Python. Our purpose is to understand AI, is to understand how machine learns in the backend, and we want to make some applications out of it, not just work on toy projects, data sets, and things like that. So, all right, I expect this will be very much challenging for you. to complete entire syllabus in just 1 month. So I'm targeting 4 hours per day, but for the live batches, it should be 4 hours per day at minimum. But then again, only if I could get the feedback of more students, then only I will decide, okay, how many hours I would teach. But expect 4 hours per day for the entire month. So, yep. All right. Then let's get started with the NumPy. So, basically, NumPy needed to be installed in your computer, in your Python environment, but you have already three environments. If you go to the VS Code, I mean, not to the VS Code, but just our labs, you are greeted with the VS Code. The entire virtual environments are installed with you. Like over here, if I click, you will see that there is one currently selected virtual environment of DS. There is Torch. I believe there were some more. One more. There are three virtual environments. So I'm selecting Jupyter kernel and it should have showed me three, but okay, it's right now showing me only two. Data science and PyTorch. What else I can do? Data science for DS for data science, Torch for PyTorch. And there was a TensorFlow environment as well. And see, if it doesn't show up, like it's not showing up for me, then all you need to do would be to go to my GitHub and find this main.py file. And over there, you would see that I have listed out like how to activate either of the three environments in your terminal. So I'm using Linux. I mean, the backend is using Linux. So that's why the source command. And to activate, let's say the TF environment, you go select this code, you go back to the lab section, and you open up the terminal. Bottom left, this warning looking sign, you click it, and then you open the terminal. My terminal I have configured to be opened at right side. I believe if you are opening the terminal for the first time, it would be opening in the bottom section. So if you want to change those settings like I did, it was something like panel adjustment, panel, terminal, something like that. It was panel setting. Okay, now I think Control Shift P and then it was panel, move panel right. See view. You can click on the view button and where did it go? View button. Move panel right. Uh, view panel and move panel left. There is an option move panel to bottom. So this is how you would be looking at it when you initially open the terminal. No? So right now I'm in the data science environment, as you can see over here. I want to start the TF environment just for an example. So that is how I do it. I just go to my main.py, copy this code, like source opt envs. This path is basically where the environment exists. So as soon as I press enter, the TF environment should be activated inside the terminal. TF environment is selected. And if you see if so many ports are open, meaning that so many notebooks were opened and are still running in the backend and could potentially slow the server down. So I recommend that whenever you see this kind of situation, close all the ports that are running. As soon as you open a IPYNB notebook, one port is opens. So there you go, TF environment. And let's see now if we have the TF environment. Nope. Our Jupyter kernel is not showing the TF environment. Let me see if I have Jupyter installed in this. So pip list give me all the package list. And if there is Jupyter inside this or IPy kernel, then we should be good to go. IPy kernel is right here. Jupyter core, Jupyter client is right here. So I believe some bugging issues is happening right now. So I will just refresh this entire page. Things like that happens with server. So I'm just refreshing the entire page. And now basically Detecting the kernels, it is saying the DS kernel I'm by default inside. So over here, this is just I had just refreshed it, and you can see the TF kernel is being detected right now. Although I'm not going to select it, we are going to work in the default DS environment. So, yep. And I'm going to move this panel to the right again because that's how I like it. It's totally your preference. Move panel right. Yep. Although for Jupyter notebooks, you wouldn't even need the terminal. So first of all, import NumPy as NP. What does it mean? It means that I have NumPy installed in my current environment of Python, which means then again that if I open up terminal and if I ask, hey Python package manager, list all the packages that you have. So it should tell me that NumPy is somewhere around there installed. NumPy, all right. Right here is NumPy, and the version is 1.26. It's very important to keep track of all the versions of NumPy because TensorFlow works with this specific version only. I mean, the latest TensorFlows are still working on 1.26 or very close by versions, but I believe NumPy 2 is also there. Then Pandas 3 has come out, so all the version conflicts happen all the time if you don't really track all the changes. But with the uh, Cookie Cloud Labs, basically, you don't need to track anything at all because I'm expecting that you guys are beginners. See, you guys have just, if you're watching this video, perhaps you guys have just enrolled into a 1 month boot camp and you guys are coming from a non-tech background. That's a specialty. I will take any kind of person from non-tech background and teach them that coding is easy. It's your brain that is important at this day and age. So I think we have talked for a lot of time. Let's get started now finally. So import NumPy as NP. It's telling me NumPy version is 1.26.4 right here. So I will close the terminal now. So if there is a Python list, I'm starting the tutorial. Uh, if there is a Python list and inside there 1, 2, 3, 4 it is, then how to convert it into a NumPy array? There's the command np.array is the function. I have imported NumPy as np. So wherever I write np, it means numpy.array. So np.array means numpy.array. This is the alias it has created for NumPy so that I wouldn't have to write with 5 letters all the time, letters or characters. So np.array inside the function brackets, there is 1, 2, 3, 4, the entire Python list I have passed. So let's run this cell and see the output. So Python list 1, 2, 3, 4, NumPy array, same thing. It's really showing the same thing. But the point is that inside the NumPy arrays, you cannot have multiple data types. And arrays are vectorized. We will talk about it when the time comes, what vectorized operations are. But at the moment, you can think about array as arrays are just way faster than your standard Python list. That's it really. So take a look. The difference is between a list, if you multiply the list by 2, the whole list gets replicated again 1, 2, 3, 4, 1, 2, 3, 4. But if you take a NumPy array and multiply it by 2, it's a vectorized operation happening right now. 2 is being multiplied by 1, 2, 3, 4. So you get 2, 4, 6, 8 over here. That's vectorization. One command and entire array, all the elements inside that particular array are following that same command of multiplying by 2. So that's a vectorized operation. How would you otherwise, do it? This is how you would do it. Something like if you have a Python list, if you have a Python list like 1, 2, 3, 4, if you want to like multiply each of these elements by 2, you would go something like for I in range. Let's not use I for apple in range. I'm just using the variable apple because why not? I'm tired of using I. So for apple in range, length of Python list, Python list, yep. Do for me this operation. Print apple multiplied by 2. So 1, 2, 3, 4 gets multiplied by 1. 2. And let's run it. So 0246 multiplied by 2 I'm doing. So Python list was, acha, I'm taking this range. For why am I taking the range? I should take just the Python list. So for Apple in Python list, take Apple and multiply it by 2. Take the element of Apple, take individual element inside the Python list and multiply it by 2. That's a non-vectorized operation, and you will see that this is very slow because this entire operation happened 4 times. 1, 2, 3, 4. One for the first element, then second element, third element, and fourth element. Instead, in NumPy operations, one single command acted upon just once, and basically that's why it's fast. But if I'm tell you one more thing, then it would be that I've read in the documentation somewhere that NumPy was written in C++ or maybe C, so that's why it is faster. But I don't really know, you don't really know, I don't care, you shouldn't care either. We are beginners anyway. So array creation, how can we create arrays? Before we move on to how we create arrays and stuff, let me show you how to read a documentation. So go to Google and basically, mm, you just go something like create a NumPy array. Create a NumPy array, and you will see a lot of things like NumPy creating arrays. Geeks for Geeks is there. Uh, the documentation is there as well. Array creation. So you will see the entire thing over here, like how do you import NumPy array, how do you create it basically. So the point is you don't have to learn the code, you just need to understand the logic behind the scenes right now. And these days we have chat gpt, so hmm, everything is very easy. I mean, coding is easy, logic is tough. Coding is easy. uh, if you have never done coding before and you are scared of doing coding, then let me tell you, coding is really very easy. In my school days, I'm from a mechanical background. So in my school days, I used to be very much afraid of coding. Like, it scared the heck out of me. So just one day it happened that I met a teacher, and then they just took out 1 hour and explained to me this Jupyter notebook. And they told me like how easy Python is. Python is really for everyone. It's just so easy. And it was at that point that I, got comfortable with coding. So I hope you get comfortable with coding very soon as well. Anyway, import numpy is np.array123. Let's print it and see what happens. So if I create np.array123, you can see 123 right here. np.0, and the shape is 3 by 3. So create for me a 3 row, 3 column, 3 row, 3 column. I mean, rows are this: row 1, row 2, row 3. So this is the first column, this is the second column, and this is the third column. So np.0 3 by 3 means create for me a 3 row, 3 column array of zeros. All right. Then np.ones create for me a array of 2 by 4 size, row 2, columns 4. So you can see 2 rows and 4 columns. np.arange start from 0, go till 10, but don't include 10, and move in the steps of 2. So take a look at the output: 0, 4, 0, 2, 4, 6, 8. Then np.linespace, uh, go from 0 till 1, but I believe 1 is excluded. Okay, but the thing is, let me show you the command first. Like, I don't usually remember what line space does. So what I instead do is create a NumPy array of, let's say, 5 elements between two numbers. Yep, it will give me somewhere along the line how I would do that. So see, np.line space. So that's why I don't need to remember. Coding is easy, logging is difficult. So the output is 0, 0.25, 5, 0.75, and 1. Give me 5 numbers within the range of 0 to 1. But just like now, right now, I notice that this 1 is also included in the output. Unlike the np dot a range where the second parameter is excluded. I don't know why that happens. You don't need to care why that happens. It just happens. What else? np.random is a library which generates random things really. So random generate for me random numbers between of shape 3 by 4, I believe. And let's check it out as well. What random numbers it gave me. So by default, the range of this np.random.rand is from 0 to 1. So right here, 0 to 1, create for me random numbers between 0 to 1. Random numbers or random decimal numbers, you can say. The shape is 3 by 4. There are two dimensions. And x dot size, what does dot size tell you? Mm, well, it's like all the dimensions multiplied. 3 into 4, 12. Okay. The data type is float, of course. Okay, what else? Then there is a range. We discussed a range already. Boolean indexing, very much important topic. So if you have, let's say, a array, we will discuss NumPy through a project, but not exactly NumPy. We will do a project. We will understand. Okay, this is why NumPy is used, and this is where it data manipulation happens. And like basically, say if you have a data, if you have collected a data from somewhere, you need to manipulate it, change it, visualize it. So that's where NumPy, Pandas, and Matplotlib come in. So over here, take a look. I'm creating a NumPy array called X, starting from 0, going on till 10, but 10 is not included. And then I'm saying create a mask for me. And mask is basically saying that X should be greater than 5. So the mask says, is my first element greater than 5? No. Is my second element greater than 5? No. Is my third element greater than 5? No. And so on till it finds the element that is greater than 5. I'm not saying greater than equal to, I'm saying greater than 5. So that's why for 6, 7, 8, 9, it's telling me true, 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 true. So 6, 7, 8, 9. If you put x and if you index it like this way with the square brackets, so understand that the round brackets that you have are for functions. Square brackets instead are there for indexing. I believe indexing or subsetting is the word, but I don't really care if it's called indexing or subsetting. But for now, I'll choose the word indexing. So if you want to index using some condition, like let's say uh, x and the condition is x is divisible by 2 or x should be even. So how would I say that? X divide equals, I should say, now divide equals 2 equals 0. Is that the condition? No, this is the invalid syntax. Okay. So I believe there's a modulus operator as well. Mm, I did it, but I don't really know what I did. So let's check. So I created a mask which says x and 2. I needed to put modulus operator, not the and operator. Modulus says basically that x divided by 2, is it showing me the remainder of 0? Is it giving me the remainder 0, which means is the number even? So it's telling me yes, number is even. All these numbers are even. With the 2, they leave the remainder 0. And I believe there is an np.where as well. np.where would you find this condition to be true? Where would you find x is greater than 2 inside the array of x? Wherever you find the condition greater than 2, just write greater. And wherever it's not true, just write lesser than 2. I believe you can write anything at all. So, yep. So for the thing 0 for the alphabet character word no. This is mathematical character 0. For the number 0, it's saying lesser than 2. For the number 1, it's saying lesser than 2. And I'm not saying lesser than equal. I'm saying, is it greater than 2? Yep, I should read it properly. So basically, this is the thing. Np.where vectorized operation. Wherever this condition is true, it will put greater. Wherever this condition is false, it will put lesser than 2. Or I should say just lesser. Yep. Fancy indexing means that you can see fancy indexing, very easy thing as well. Numpy.arange create for me a array from 0 to 9 and give me the indexes 1, 3, 5, 7. Remember that indexes in Python starts from 0. So indexing, if I run it, it will give me 1, 3, 5, 7. Let me change it a little bit. I'm saying np.arange start from 10 and go till let's say 20. Yeah, then give me the first index, which is the actually the second index. So first index would be like 0th index. Let me also show you what the 0th index would look like. So 0th index is 10 itself. First index is 11. Remember, Python's indexing starts from 0, 0, 1, 2, 3, 4, not 1, 2, 3, 4. No. All right, reshaping. Let's discuss reshaping. It's very important topic. I keep saying very important topic with every topic I come across because I chose all the topics that are important only. Wow. Anyway, I have a X. This right here is the X. And if I want to reshape, I can reshape it. Let's say I want to reshape it into one row and as many columns as you want to make. At the moment, I've not executed it. At the moment, take a look. There's only one list like bracket, meaning that it's a one-dimensional array. I'm reshaping it into a two-dimensional array, which says one row and -1 means adjust the column count accordingly. So take a look. Right now there are two list like brackets. So let's say I'm taking two rows and adjust the columns accordingly. So it's created for me. It has created for me two columns and 1, 2, 3, 4, 5, 6. Six, I mean, two rows and six columns it has created for me. So that's -1. You could explicitly have said, like, I want two rows and six columns. Output would be the same, but I just prefer using the -1 way because I don't have to remember like 12 like if the entire data is 12, 2 comma 6 would be there. I wouldn't have to remember the 6. So 2 minus 1 does the job. Let's say if I change it to 3 minus 1, it would be like 3 rows and whatever columns are left. So by default, the order is going 0, 1, 2, 3 for 3 rows. So 4, 5, 6, 7. So the rows are filling first. All right. So check it out. What did I do? Mistake. Okay, broadcasting I've not explained, but you can check it out on your own. But let's say I ran the cell. If you have a array of 1, 2, 3, then you have created an array of 3 by 3 shape. And let's say you want to add a plus b. How would you add two arrays of different sizes? So that's where broadcasting happens. So 1 to 3 would be replicated to a 3 by 3 matrix, and then the 1 2 3 matrix would be added to 1 1 1. So the output would be 2 3 4 2 3 4 2 3 4. So 1 2 3 is added first to the first row, then to the second row, then to the third row. That's what broadcasting means, because otherwise, see, it wouldn't have happened now. Like, take a look. Right now my a is this array, my b is this array. How would you otherwise add one thing to another? I mean, where's the rule that says, okay, add row 1 to row 1 only, or perhaps row 1 to row 2 only? So this is the vectorized operations going on. Broadcasting it is particularly called. So broadcast the array of 1 by 3 into 3 by 3, and then add the two 3 by 3 dimensional arrays. That's what broadcasting means. Factorized operations I've already discussed. Aggregations will make more sense when we discuss pandas. But just as an example, you can take a mean of the array, you can take calculate the minimum or the maximum. What else? Linear algebra, if you want to do matrix multiplication, I keep forgetting this symbol of at. So if you want to do matrix multiplication inside NumPy, just Google search like do matrix multiplication in NumPy. Like let me show you. NumPy matrix multiplication. So np.matmul is there, and what else? This operator is also there. So I think both of them means the same thing really. The preferred and most readable syntax for standard matrix multiplication in Python 3.5 plus. It's specifying broadcasting rules. So this is the, I think, Python's inbuilt matrix multiplicator, and np.matmul would be the NumPy version of it. If you want to take a dot product, there is a NumPy.dot as well. There are a lot of operations you can do with NumPy. Random number generation, then again, go Google search for it. Stacking arrays, yeah, this is important in computer vision where you stack images from left to right, stack images from top to bottom. So images are nothing but arrays only. So array of pixel brightness value. So pixel or basically a brightness can go from 0 brightness to 255 brightness. 0 meaning completely dark pixel, 255 meaning completely white pixel. So anything in the middle of 0 to 255 would be a gray pixel, sort of. So over there in computer vision, we use VStack and HStack. So take a look, just quick look over here. There's the array 1 to 3, array B, which is 4, 5, 6. If you vertical stack it, then these gets stacked on top of each other. If you horizontal stack it, then they are stacked alongside each other. 1, 2, 3, 4, 5, 6. Although I usually forget VStack and HStack, so I just Google search like how to vertical stack two arrays, how to horizontal stack two arrays. Split array into two, that's what this thing means, as you can see with the output over here. Saving and loading files, then again, just go Google search for it. And rest of the file read on your own, there isn't much to read with. So yeah, that's the NumPy live stream, and I hope you have a good day. I hope you are able to understand the logic behind NumPy and the very fact that see coding is not important, it's logic that is important. So yep, thank you for watching. You will not be able to reconnect your